exactly typecasting is. Let's revise the definition of typecasting one more time in brief. Typecasting is a process of converting the data from one type to another type for a temporary period. Now, the data can move from lower size to higher size or higher size to lower size. The only thing which you are supposed to use, you are supposed to use the data type keyword in the brackets. We call that as a typecasting. You identify two types of typecasting. One as internal, which happens automatically during the arithmetic evaluation of the instructions. And the other one is externally, where the programmer will force the data to be converted. Let's use one of these typecasting programs. Assume that I wish to do some mathematical operations on some integer values. So let's say that I wish to say add, subtract, multiply and divide two variables, say a and b. For that, let's put a simple program and illustrate the typecasting in these programming instructions itself. So let's include the header file, #include std.h. Then I'll say void main, which is the title for the function. Now, wish you can read the values from the user, or you can take, since this illustration program, I'll take int a as say 10 and say b as say 3. Now, I wish to add, subtract, multiply and divide a and b, and it should display the results with proper messages. If you feel that why a as 10 and b as 3, you can take the values from the user. Yes, declare only two variables a and b, ask the user to enter two numbers and read them. So when I ask the user to enter two numbers, you can say printf, you can say enter two numbers, scanf %d, ampersand of a, ampersand of b. If you feel you wish to read, you can read them. Otherwise, let's illustrate a and b with some standard values, let's say 10 and 3. Now, if I ask you to do addition operation, we have a mathematical operator plus. If I ask you to do a subtraction operator, we have a minus symbol. Multiplication, asterisk, and division, we have slash. Let's try these operations. So I'll directly display the addition at this place. I'll say printf sum equals to, let me say the value which is supposed to be displayed is %d /n, comma. So here I'll say a plus b. A printf argument can even be an expression. If a printf has got an argument as an expression, it means that it will display the result of that particular expression at the place where the format specifier is specified. So here the format specifier is specified after equal to. So here %d is now be replaced with the result of a and b. So /n will get the cursor next line so that the output will appear on separate lines. Let's put the difference as printf difference. Now, difference of two integer numbers will be integer value, hence I'll say %d again /n, and this %d is now going to get a minus b results. So add a and b and display it next to sum equal to message, subtract a and b and display it next equals to this particular part. So here we are yet to reach to the title, that is typecasting. Because when we add two integers, the result is integer. When we subtract two integers, the result is integer. Hence, we don't require a typecasting process for these instructions. Let's try multiplication. So I'll say printf multiplication. Now multiplication is again an integer value, hence %d /n, a asterisk b. So value of a is 10 and b is 3. So in this case, multiplication equal to 30 displayed. Let's put the division operation. So now here we're going to have the title justification. So let's divide the two numbers. I'll say printf division equals to. It is said that when we divide 10 and 3, mathematically the answer will be 3.33, and that is what I'm supposed to display on the screen. If I use a %d specifier, it means that it will display only 3, not 3.33, which might be incorrect. So let's try to display the value as 3.33 itself. So 3.33 is a fraction value, hence let's put a %f specifier at this place. So I'll use /n. If you wish, you can avoid this because this is the last output. So last output, after that you can leave the cursor on the same line, you can get the cursor on the next line. So now if I directly say a/b, let's check out what exactly will be the result. Don't jump to a conclusion till we have the entire process done. So here it says division equals to, as it is, percentage of a/b. Now for that, let's identify the operator and its property. The operator which I use is slash, and the value of A is 10 and B is 3. So 10 by 3. 10 by 3. Mathematically it might be 3.33. But slash operator will not get 3.33, it will get 3. Do you remember why it is? Yes, you got it right. So it says that the value of A is integer, B is also integer. Slash property says that integer divided by integer is always an integer value. Hence the result for you it might be 3.33, but for the system it is still 3. So now how do I get 3.33? Until unless I convert one of these data to float, it will not work. So let's convert either A or B to a float type from integer. Here we are using a typecasting process. So the division operation doesn't yield us the exact results as per our mathematical rules. It uses its own rules, saying that when numerator is integer value, denominator is integer value, the result is always integer value. Convert either A or B to its float value. So what I'll do is, I'll put a typecasting keyword, I'll say float for A. So when I put a keyword float for A, it means that this A was of type integer is now converted to float. So the numerator turns out as 10.0, not 10, divided by still an integer value, that is 3. So 10.0 by 3 is now 3.33. So it displays the result as 3.33 and displays the exact result after this particular division operation. So a typecasting can be done manually by the programmer, which can be applied to any one variable of your choice. So in this, if you wish, you can do the typecasting to a numerator value, or you can do it for a denominator value also. That's about the typecasting operations. Thank you.